So a lot of things can go wrong here, and I think that's part of the excitement. All right. So I am VPN'd into our own lab. The intent was to deploy what you're going to see here in the OPI lab, although there were some difficulties with hardware that prevented us from doing it. What's important to realize is there's nothing technically gating us from moving what you see here into the OPI lab. I'll talk about that later as well. So let me first go into the directory. And I'd like to also bring a diagram into the picture. So the first thing I'm going to do is make sure that I start with a clean environment, because this is actually a live environment, so I don't want to break the demo because something else has been running. And what we see here is a cluster, right? So in the end, we have the OPI APIs behind the scenes, and what you then build on top is an implementation in OpenShift or Kubernetes. Like OpenShift is the Red Hat version of Kubernetes. So at the top, you can see a bunch of nodes, and on the bottom, you can see DPUs. So let me zoom in. So at the top, you can see 3 master nodes, just like any other normal cluster, 3 master nodes. That's what you see here. And then you have 3 worker nodes. And inside each of these worker nodes, you can see a DPU, right? So if I go back to the diagram, 3 worker nodes, that's what I'm showing here, x86 servers, and then 3 DPUs, okay? And everything is working in one environment. What's important here is that we're talking about an IPU, an Intel card, a Marvell card, Octium 10, and Phantom Lake. So 3 vendors all in one environment, seamlessly integrated, right? So within this whole infrastructure, there's a lot of other stuff going on. So it's useful to have the user, to give the user the ability to see what the state is. And so you have a command called OC-get DPUs. So this is, if you're familiar with Kubernetes, it gets you custom resources, gets you information, and you can see all the DPUs that it's detecting. So you see 6. Why do you see 6? Well, what this is telling you is that on each server where there is a DPU, there's 2 sides. So there's the card, and then there's the host side, and we're running a piece of software on each side, and they're looking at the hardware. And so each one of these, you see it twice, because on one side is the DPU and one side is the host. So it's as simple as that. And we give them names, a unique identifier. We can figure out how we want to display this, but just for the sake of the demo, it's a unique identifier. And then you can see what kind of DPU you're talking about, and the state being true. So depending on the DPU, it might be in a healthy state or not so healthy state. So that's what you see here. So in more detail, let's continue. So behind the scenes, there's a bunch of components running to get this working. And if you go into the namespace, I hope this is big enough. If you go into the namespace that contains all these components, you'll see that you have a bunch of DPU daemons. That's a component running, again, on the host and on the DPU. So that's what you see here. And on each of the different sides, right? So these things are making it so that everything is managed seamlessly for you. And all these components are using the APIs, the OPI APIs, right? And then we have a controller, a network resource injector. Those are all details, not so important, although these are important. So the VSPs, the vendor-specific plugins, of course, since vendors have particular ways of managing DPUs, we need to put that detail somewhere. So we put it into what we call a VSP, we hide it away, and from a user perspective, you don't even need to know about this, although the system needs to recognize that which DPU is running where, and it needs to start those components so that the hardware is managed. Okay, so next let's start a demo. This is where it will become a little bit more interesting. So we're going to first do some cleanup, and then we're going to start a pod on the Marvell card, and I will start a pod on the Phantom Lake. So what's important here is that from a user perspective, you're literally using standard Kubernetes primitives, right? You're applying a YAML file and not yet another YAML file. And then what you see is you get 2 pods. So if I run this again, as I was talking, it had enough time to make sure that those come up. So in this environment, now you see 2 pods in the default namespace. One is running on the Marvell card, one is running on the PTL, on the Phantom Lake. That's what you see here. Each one has an IP address. So you see, that was as easy as it gets from a user perspective. Behind the scenes, a bunch of OPI-related things happening. So now we can create more pods. And, or is this the same? Yeah, it's the same. So what I'm going to do next is I'm going to create the deployments. So on the host side, going back to my diagram here, I showed you that you were able to create these two pods here, right? I'm now going to create a deployment on the host side, and it's going to create some pods on x86 and some of them on this other x86 node, all plumbed into the data plane. So if I create this, going back here, so we get 5 pods, and every time I run this demo, it's a little bit different because Kubernetes scheduler will figure out where it makes sense to run these. We have constraints like we need the DPU devices and we need like particular labels, but otherwise the scheduler is free to run it where it wants. And we see it that it ran it 3 times on the Phantom Lake and 2 times on the Marvell card. So if I get this again, so now all of these are running, and that means that it's plumbed into the data plane, going through either the Marvell card or the Intel card. And the only difference here, and that's what I want to point out, is literally, of course, a different name, but only this is the real difference here. We're just selecting a different device. It's really emphasizing the fact that these are industry standard commands. Everything is green. Let's just double check that everything is working correctly. Yeah, so we did that. And then we'll look into the IP addresses. So inside of the pods that are running on either card, we'll look at the IP addresses. So that's what you can see here. These are shown here. And then we're going to show that ping actually works. So because everything is now integrated into this like unified environment, all these pods can talk. And that's important, right? So this pod can talk to this pod can talk to this pod can talk to this other pod. Every pod can talk to each other, right? And this is really the power of when you have OPI, right? Because if you would have a vendor-specific solution for a particular card, that card would probably be able to talk to the same card from the vendor, but not to a different card, right? And because we've unified everything, everything can talk to each other. Okay, and then I'm going to show that, yeah, there's more ping examples here. So this is going from the host to the card as well. So that works as well. So you can look into the details, but the gist is really that everything can talk to each other. So if I now, instead of using a simple workload, let me just clean this up. I'll start using Nginx instead. So since you have this diagram here, the blue pods here, those are just normal pods. That's important. So we can switch out the pods for something like Nginx, right? And so I'm going to show that now. So this case is going to deploy it on the Marvell card. You see it's also pretty fast. So skip all of this. I think what I can do here is deploy this one straight. So we're going to deploy the Nginx pod. Takes a while because it's configuring the IP addresses as well. Might have skipped too many steps. Oh, it's ready. So Nginx is now ready. That's good. And if we actually check the deployment, you can see Nginx is ready. And then In this case, let's check where it's running, because we did use selectors to force it to run on a particular DPU. In this case, it's running on the Marvell card, right? And then we can, yeah, so that was good. Then we can run a demo to do some kind of workload. And I think the next presentation will talk about that more. Although, because we're doing demos, sometimes things go wrong. So imagine that this worked, because it did earlier today. So that's all good. So clean up, and we're going to move that to the Phantom Lake. And again, the only difference is literally the node selector. So we select it to run on the Phantom Lake instead. So it's now coming up on that Phantom Lake card. So now we ran it here first, and we moved it here. Hopefully. So let me just run the cleanup first. Hopefully I can get this working. And then run it from here. Yeah. And again, let's have a look. Those are the nodes, and let's look at this one in particular. So you can see now the Nginx pod is running on the Phantom Lake, and hopefully we can do this part where we do some kind of prediction. So this is actually going through that Nginx pod and to the host on that side. Okay, so that this works pretty nicely. I have a stretch part of the demo. Hopefully we get to that at the end, and maybe we break the cluster, and that's good information to have as well. So let me go back